In the expansion of 1 plus kx to the power of n, where k is non-zero and n is a positive integer, the coefficient of x is 24 and the coefficient of x squared is 264. Find the value of n and k. Now, before we even start to solve this problem, we're going to recognize that there are two unknowns and we're given 2 bits of information, which means we're going to have to solve a simultaneous equation at some point. So let's use those 2 bits of information that we have. First of all, the coefficient of x is equal to 24. So we need the coefficient of x. So that means we're doing with n choose something, 1 to some power, kx to some power. Because it's the coefficient of x, this needs to be 1. So this is 1 and this is n minus 1. N choose 1 is just n, or if we use the full formula, it's n factorial over 1 factorial n minus 1 factorial. But that's going to simplify down to n times n minus 1 factorial, which is n. This is 1 and this is kx. On the other hand, for the coefficient of x squared, we've got n choose something, 1 to some power, kx to some power. That needs to be 2 to get the x squared. So this is 2 and this is n minus 2. This is n factorial over 2 factorial, n minus 2 factorial, which is n minus 1 over 2. Because I can expand this out to n minus 1, n minus 2 factorial, and they cancel. This is 1, and this is k squared, x squared. So my coefficient here is n times k, and I know that's equal to 24. And my coefficient here is n minus 1 over 2, k squared, and I know that is equal to 264. I now have my 2 equations. Once I have my 2 equations, I can solve them simultaneously. I'm going to do this by rewriting this as k equals 24 over n, and substituting that into here to get n minus 1 over 2 times 24 over n squared is equal to 264. There are other ways to approach this. This is the way I'm going to do it. To simplify this, I'm going to multiply through by 2, divide through by the 24 squared, and I get n minus 1 over n squared is equal to 11 over 12 when I do that. Multiply through by the n squared and the 12, I get 12n minus 1 equals 11n squared. Expanding gives me 12n squared minus 12n equals 11n squared. Rearranging, n squared minus 12n equals 0. And finally factorizing, n minus 12 is equal to 0. That means n is either equal to 0 or 12. Since n can't be 0, n has to be equal to 12. So n is equal to 12, and k is equal to 24 divided by n, so k is equal to 2.